Hello everyone. Today we will learn forward difference and Newton's forward interpolation formula. So first of all, we will learn what is interpolation. So interpolation is the process of estimating the value of a function at an intermediate point, or the process of finding the value of a function inside the given range is called interpolation. What this means? This means that suppose we have some data set, some values for x and corresponding fx, and those are suppose x naught, x1, x2, in this way xn. Okay, and corresponding values of fx are f of x naught, f of x1, f of x2, in this way f of xn. Now, suppose we want to find out some functional value fx where this x lies within the interval x naught to xn other than this given points. The process by which we can find out this functional value fx, that is known as interpolation. Okay. And now today we will learn Newton's forward interpolation formula. So in case of Newton's forward interpolation formula, we have to go through forward difference. So forward difference, that's this is denoted as forward difference operator denoted as delta. This is delta. Now this is applied only when the values of x, these values of x must be equispaced. These values of x must be equispaced. Means x1 minus x naught should be equals to x2 minus x1. In this way, xn minus xn minus 1, all this should be equal. So delta fx, the definition of this is f of x plus h minus fx, where this h is the interval of difference. Now, this delta fx is nothing but the first order forward difference. Similarly, we will have second order forward difference, that is denoted as delta square. And delta square fx equals to delta of delta fx, which is nothing but delta of f of x plus h minus delta fx. And again, delta of f of x plus h, by this definition, if I put the value, I will get f of x plus 2h minus fx and minus delta fx, which is nothing but f of x plus h minus fx. So ultimately, we will get this value. Now, similarly, if I find out delta cube fx, delta cube fx is nothing but delta square of delta fx, which is delta square of f of x plus h minus delta square of fx, because delta fx is this value. So after putting the value of delta square f of x plus h by using this definition and delta square fx, we will get the value is this one. Now we can proceed in the same way. And lastly, we will get delta to the power n fx. If I find out this delta to the power n fx, this will be nothing but delta to the power n minus 1 f of x plus h minus delta to the power n minus 1 fx. Now, using the functional value, we can also give some value. We can write the value as ncn f of xn minus c delta fx. Here we have plus minus delta squared plus minus plus. Then delta cube also we have plus, then minus, then plus, then minus. So here also we will get an alternative series. So plus, then minus, and minus, the coefficient will be n c n minus 1 f of x n minus 1 plus n c n minus 2 f of x n minus 2 minus dot dot dot. So the last term will be plus minus 1 to the power n f of x not. Okay, so this will be the value for delta to the power n fx. Now, in particular, suppose we have the given data set x naught, x1, x2. In this way, we have xn. Here, corresponding value functional values are f of x naught, f of x1, f of x2. In this way, f of xn. So, from this given data, if I want to find out delta of f of x naught, which is nothing but f of x1 minus f of x naught, since in the previous slide we have delta fx is f of x plus h minus fx. So from this we can say that delta f of x naught is f of x naught plus h. Now what is x naught plus h? X naught plus h is nothing but your x1, because all these are equispaced values. Here simply x1 minus x naught equal to x2 minus x1 equal to at last xn minus xn minus 1. All this will be equal to h. So delta fx naught I can write fx1 minus fx naught. Similarly, if I want to find out delta of fx1, it will be f of x2 minus f of x1. Okay. So in this way, we can find out up to delta f of x n minus 1 from this given data. And the value will be f of x n minus f of x n minus 1. We can't find out delta f of x n since f of x n plus 1 is not provided in the given data. So these all are first order forward differences. Similarly, we can find out second order forward differences, third order forward differences in this way up to delta to the power n, nth order forward difference, that is delta to the power n. If I proceed for delta square f of x naught, we can write this as delta f of x1 minus delta f of x naught. Or also we can write down as f of x2 minus 2 f of x1 plus f of x naught, as we have written in the previous slide. You can see here it is. Okay, just we have put here the particular values. So in this way, we can find out delta square f of x n minus 2. Up to this we can find out, and it will be delta of f of x n minus 1 minus delta of f of x n minus 2. Also we can write as f of x n minus 2 f of x n minus 1 plus f of x n minus 2. So these all are second order forward. In this way we can carry forward and we can go up to nth order forward. So this is all about forward difference. Now where we will do some problem in case by using Newton's forward interpolation formula, we will show how to make the table, forward difference table. Now here, here I am showing this, how to make the table. Suppose this is for this column for x, x naught, x1, x2 up to xn. The next column is for f of x. So just 1 minute. F of x, f of here, f of x naught, f of x1, f of x2. In this way, we have f of xn. So, suppose the next column for delta fx, then delta square fx. Then, in this way, if I proceed, suppose I will have at last delta to the power n fx. So here the first value I will get for delta f of x naught, and the value will be equal to f of x1 minus f of x naught. Next I will get delta f of x1. The value will be f of x2 minus f of x1. So from this two, I will get this. In this way, at last, I will get delta f of xn minus 1. And the value will be f of xn. And in the previous, the previous term will be f of xn minus 1. So from this 2, I will get this one. And this is for xn minus 1, right? So next, from this 2, I will get here delta square f of x naught. The value will be simply delta f x1 minus delta f x1. So in this way, at last, I will go to delta square f of xn minus 2. So in this way, at last, I will get delta n f of x naught. And this value I will get from the previous column here. We have two values. Second minus the first will give this value. So every time what to do, suppose I want to find out the values from of this column for this column. So I have to go to the previous column. Second minus first gives the value, this value. Third minus second, fourth minus third. If I proceed, I will get all the values. Similarly, for this column also, go to the previous column. Second minus first, third minus second. In this way, we will get all the values. So proceed for the nth order. In this way, I will get the table. This is nothing but the forward difference table. Forward difference table. This is nothing but forward difference table. Now come to one theorem. Let fx be a polynomial of degree n. Then the nth order forward difference of fx is constant and all other higher order forward differences are 0. So let fx is this polynomial a naught x to the power n plus a1 x to the power n minus 1 plus dot 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 a n minus 1 x plus an, where a naught, a1, a2 up to an all are constant. So if I use forward difference on this function fx, on this polynomial fx, so then delta to the power n fx, we can get a constant value. And that value will be a naught into n factorial into h to the power n. And delta to the power n plus 1 fx, delta to the power n plus 2 fx, and so on will be 0. Actually, one thing, if we have a polynomial, suppose fx is a polynomial of degree, suppose 5, then if I use delta on the polynomial fx, then it will be a polynomial of degree 4. Delta square fx, it will be a polynomial of degree 3, and so on. So in this way, the degree of the polynomial decreases as we increase the order of the forward difference. Next, we will have Newton's forward interpolation formula. So Newton's forward interpolation formula is used to approximate values of a function for equally spaced data. So suppose we have some values for x and corresponding values for x, right? So x naught, x1 up to xn, f of x naught, f of x1 up to f of xn. These are the values for fx corresponding to x. Now, suppose I want to find out some fx where this x lies within the interval x naught, xn, other than these given points. If this x, this is nothing but interpolating point. This is known as interpolating point. Interpolating point. This interpolating point x, if lies in the near the beginning of the table, then we can use Newton's forward interpolation formula. And one more thing, the values of x must be equispaced. That means x1 minus x naught, same as x2 minus x1, same as x3 minus x2. In this way, xn minus 1, all values are equal. Here then, fx can be written as this. This is the formula. So here I will derive it. Actually, what we do, we have some certain data set. Suppose x naught, f of x naught, x1, f of x1, x2, f of x2. In this way, we have xn, f of x. These are the data set we have, where x1 minus x naught same as x2 minus x1, same as x3 minus x2, same as xn minus 1, which will be equal to h. Now here we will fit one polynomial px such that p of x naught will be equal to f of x naught, p of x1 will be equal to f of x1, p of x2 will be equal to f of x2. In this way, p of xn will be equal to f of xn. So we will here find out the interpolation polynomial p of x. So one more thing, since we have how many data sets? We have n plus 1 data sets. Starting from 0 up to n, we have n plus 1 data sets. So from this n plus 1 data sets, we can assume that px will be a polynomial of degree n, at most degree n. So here we are assuming that the polynomial is a naught plus a1 into x minus x naught plus a2 into x minus x naught into x minus x1 plus dot 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 up to an into x minus x naught into x minus x1 up to x minus xn minus 1. So this is the considering polynomial. Now a naught, a1, a2 up to an all are unknown and we have to find out these values. We are actually here we are deriving the Newton's forward interpolation. We will get from this the considering polynomial, we will get this as the formula. So here, suppose this is the equation number 1. Now in 1, if I put x equals to x naught, then 1 will become, the left hand side will be p of x naught. Now, as we put x equals to x naught, the left hand side will be p of x naught. And p of x naught is nothing but your f of x naught. See, here we have assumed px in such a way that p of x naught is equals to f of x naught, p of x1 equals to f of x1 and so on. So we can write down p of x naught as f of x naught, which is equals to a naught, and the rest all other terms will become 0. So simply a naught will be your f of x naught. Now in 1, if I put x equals to x1, then the left hand side will become p of x1, which is nothing but your f of x1. So this will be your the right hand side will be a naught plus a1 into x1 minus x naught, and x1 minus x naught is nothing but your h. So I can put here this as, I can put here as h, a1 into h, and all other terms will become 0. So from this What is your A1? A1 will be your f of x1 minus a naught, and already we have got the value of a naught, that is equals to f of x naught divided by uh, divided by h. F of x1 minus f of x naught divided by h, that is your a1. So now f of x1 minus f of x naught, using delta, I can write this as your delta f of x naught by h. That is nothing but your a1. So a naught we have got as f of x naught. Next a1 I have got as delta f of x naught by h. Next, to find out x2, what I will do, I will put in one, put x equals to x2. If I put x equals to x2, then the left hand side will be f of x2 equal to a naught plus a1 into, when I am putting x equals to x2 here, when I am putting x equals to x2 here, this will be x2 minus x naught, and this will be your 2h plus a2 into x2 minus x naught, again 2h into x2 minus x1, that is your h. And the rest terms will become 0, since the rest of all other terms will contain x minus x2. So I will get up to this. So from this, a2 will be your f of x2 minus a naught, minus we can write down, a naught. What is your a naught? A naught is your f of x naught. Okay. Plus a1 into just 1 minute. So this is your a1 into 2h. And what is the value of a1 just got? Delta f of x naught by h into 2h. And it will be minus, right? This will be minus. This will be minus, okay? So, so this implies a2 equals to f of x2, and from here h cancelled out. So delta f of x naught, again if I put the value, this will be f of x1 minus f of x naught. So f of x1 minus 2 f of x1 I will get, and here minus minus plus 2 f of x naught minus f of x naught, that is plus f of x naught by, acha, here I have, here I have here I have 2h square. So if I divide this by 2h square, I will get this as the value of a2, which is nothing but a2 will be equal to f of x2 minus 2fx1 plus fx naught is nothing but delta square f of x naught by 2h square. So in this way, if I proceed, then I will get, in this way, if I proceed, I will get an equal to, here I can write down a3. A3 will be C. A naught is nothing but your f of x naught. Similarly, a1 is delta f x naught by h. A2 is delta square fx naught by 2a square. So if I proceed for A3, I will get delta cube f of x naught by factorial 3 into h cube. And an will be delta to the power n f of x naught by factorial n into h to the power n. So if I put these values of a naught, a1, a2 up to an in 1 in this equation, I will get p, I will get uh, p of x equals to, so what is your a naught? A naught is simply f of x naught. So I will put it here, f of x naught plus, next what I have? I have a1 to x minus x naught. So I can write down x minus x naught into a1. And what is your a1? A1 is delta f of x naught. You can say delta f of x naught by h. I have. Plus, next I have x minus x naught into x minus x1 into a2. And what is your a2? A2 is delta square f of x naught by 2 into h square plus x minus plus x minus x naught x minus x1 into a3 into x minus x2 into a3. And what is your a3? Delta cube f of x naught by factorial 3 into h cube plus, I can write down the last term and see the last term, x minus x naught into x minus x1 up to x minus xn minus 1. So x minus x naught, x minus x1 up to x minus xn minus 1 into an. And what is your an? Delta n f of x naught by factorial n into h to the power n. So here we can write down. Now we will introduce one u. What is your u? U is your u is x minus x naught by h. I will introduce one new variable u, which is x minus x naught by h. If I put this value there, what I will get? I will get p of x equals to p of x, I will get as f of x naught plus, see, x minus x naught by h is your u. So I will write u into delta f of x naught plus x minus x naught by, here we have h square. So I can take one h in this denominator. So I will have here u. Now x minus x1 by h, another h I can take. See, I have x minus x1 by another h I have. So this can be written as x minus, what is your x1? X1 is x naught plus h. So x naught plus h by h. Now x minus x naught by h minus h by h, that is 1. So u, that is equals to u minus 1 I can write. So here I can put this as u minus 1 sorry, here I have u. Next, this is u, and x minus x1, I have x1, x minus x1 by h is u minus 1. And what is remaining? Delta square f of x naught by 2. That is nothing but factorial 2 I can put. Plus, for the next, x minus x naught by h, that is u, x minus x1 by another h, that is u minus 1. Similarly, x minus x2 by h, that I can put as u minus 2 by factorial 3 I have into delta cube f of x naught plus the last term will be u minus 1 in this way u minus n plus 1 by factorial n into delta to the power n fx naught. So here this is the formula. As I derived it, the same thing here it is. This is the formula. Now we will do one problem. The first problem is using using Newton's forward interpolation formula, find y at x equals to 5 from the following table. So here the values of x are 4, 6, 8, 10. So here 6 minus 4, that is 2, 8 minus 6, 2, 10 minus 8, 2. So all values are equispaced. So we can apply Newton's forward interpolation formula. And one more thing, the value interpolating point x 5 that lies in the near the beginning of the table. So I can use Newton's forward interpolation formula. Now in the Newton's forward interpolation formula, I need u. Here what is your u? U is x minus x naught by h. So here to calculate u, I need x, x naught and h. X means the interpolating point, that is 5. X naught is the initial value of x, that is 4. H, here h is 2. H is equals to 2. So when I am calculating u, x minus x naught by h, that is 5 minus 4 by 2, that is 0.5. That is your u. Now I will make the table. Now the table is, here it is. So the values of x, corresponding value of y. Now delta y, delta square y, delta cube y, that I have to find out. How to find out? Simply t minus 1, that is your 2. 8 minus 3, that is your 5. 10 minus 8, that is your 2. Similarly, for delta square, 5 minus 2, that is 3. 2 minus 5, minus 3. Then for delta cube, minus 3, that is minus 6. So this is the forward difference table. Now, by using Newton's forward interpolation formula, this is the formula. Fx naught, here you see, I have to use fx naught, delta fx naught, delta square fx naught, delta cube fx naught, all this. So from the given data, you can see this is your fx naught, this is your delta fx naught, this is your delta square fx naught, delta cube fx naught. So these values we have to use. This first values we have to use. So if I put this value, we will get f of 5 as 1.25. So this is one problem. Another problem we have, using Newton's forward interpolation formula, find the cubic polynomial which takes places the following values. Here the values are given 0, 1, 2, 3. Why cubic? Because here here it is mentioned that cubic. Why cubic? Cubic means we have 4 values, 1, 2, 3, 4. 4 values means we can assume that the degree of the polynomial, highest degree polynomial will be 3. So cubic polynomial we will get. So here also you have to make the table like this, and here also you have to find out the values of u. Now we have to find out the polynomial, not any particular value of fx. We don't have to find out any particular value. We have to find out the polynomial. Now we have to find out the polynomial. What we have to do here? We have to find out the value of u. So before finding the value of u, here you have to write down x naught. What is your x naught? X naught is your 0. What is your h? H is your 1 minus 0, 2 minus 1, 3 minus 2. That is nothing but 1. So u equal to x minus x naught by h. And what is x? X in this case we will keep as x because I need the polynomial. So x minus x naught is 0. by h is your 1. So simply you will be your x. So this is the table, forward difference table. 2 minus 1, 1. 2 minus 1, 1. 1 minus 2 minus 1. 10 minus 1, 9. Minus 1 minus 1 minus 2. 9 minus minus 1, that is 10. 10 minus minus 2, that is 12. So here the table, and since we are using forward difference step, Newton's forward interpolation formula, I have to use 1, this 1, then this 1, this minus 2, then 12. These values will be used. So this is the yx. We have to find out that's a polynomial of third degree polynomial. So P3 you can denote it as. So fx naught, that is nothing but the fx naught is 1. Fx naught is 1. Next, u, we have got x by factorial 1 into delta fx naught, that is 1. Next, x into x minus 1 by factorial 2, delta square fx naught is minus 2. Here it is. Next, x into x minus 1 into x minus 2 by factorial 3 into this 12. So we have put these values, simply simplification. After simplification, we will get these as the polynomial. So here it is. Here to here it is forward interpolation formula. I think everyone can do problem using this formula, and also you can derive the formula. Thank you very much for today. Thank you.